For over 400 years, humanity has been on this incredible quest to see farther and deeper into the cosmos. It's really a story of our own curiosity, where every amazing new discovery came from solving the problem that the last discovery created. Just look at this. On one side, you've got a simple tube with a couple of lenses that completely changed our place in the universe. And on the other, a gold-plated cosmic time machine. So, how in the world did we get from here to here? Well, that's the journey we're going to take today. So the first and maybe the most fundamental problem was actually pretty simple. It was our own eyes. We could look up and see the stars, sure, but we had no way of grasping what they really were. The very first telescopes were basically humanity's first shot at breaking past our own biological limits. These were first invented by Dutch eyeglass makers, and the design is just so simple, it's brilliant. You have a front lens that collects light and focuses it down, kind of like a magnifying glass. Then the eyepiece, it grabs that focused light and expands it, shooting a much bigger image right into your eye. It's simple, yeah, but absolutely revolutionary. So when Galileo Galilei built his own, way more powerful version and pointed it up at the moon, he didn't see some perfect, divine crystal ball like the ancient Greeks thought. Nope, he saw a world, a real place with mountains and valleys, just like Earth. And with that one single observation, centuries of what everyone thought they knew just started to unravel. But he wasn't done. He then points his telescope at Jupiter and sees these 4 tiny little specks of light dancing around it, moons. This was it. This was the first undeniable proof that not everything in the heavens orbited the Earth. And if smaller things could orbit bigger things out there, then, well, maybe, just maybe, Earth wasn't the center of everything after all. And for what? For simply reporting what he saw with his own 2 eyes. For this, Galileo was dragged before the Roman Inquisition and spent the last decade of his life under house arrest. It's a pretty dramatic reminder that changing our view of the universe, well, it has always come at a price. Okay, so Galileo's discoveries lit a fire under everyone. People wanted to see even farther. But this, of course, created a brand new problem. To see deeper into space, you gotta collect more light. And that means you need bigger lenses. The thing is, glass is incredibly heavy. There's a very real physical limit to how big you can make a lens before it just collapses under its own weight. And this is where Sir Isaac Newton comes in. His idea was a total game changer. Why bother bending light through super heavy glass when you can just bounce it off a mirror? So you have this big curved mirror at the bottom of the tube that gathers all the faint light, focuses it up onto a smaller angled mirror, which then just shoots it out the side into an eyepiece. Brilliant. And this really shows you the trade-off, right? Lenses, they give you a slightly sharper image, no question. But mirrors can be built almost as big as you can imagine. And since the whole game in astronomy is to collect as much faint, faraway light as you possibly can, mirrors quickly became the clear winner for seeing deep into the cosmos. The proof is right here. The biggest refracting lens ever made weighs 500 pounds. That's a quarter of a ton. It was an absolute masterpiece of engineering for sure, but it was also the end of the line. We physically could not build them any bigger. So now that we could build these giant reflecting telescopes, astronomers started noticing these weird, fuzzy patches of light scattered across the night sky. They called them nebulae, which is just Latin for clouds. And the next great mystery became, what are these things? The key to cracking this case turned out to be a really special kind of star called a Cepheid variable. It pulses, going from bright to dim at a super regular rhythm. But here's the crucial part. Astronomers figured out that the slower the pulse, the brighter the star actually is. You can think of it like a cosmic yardstick. So in 1923, an astronomer named Edwin Hubble decides to use this yardstick. He finds one of these Cepheid stars inside the Andromeda Nebula. He measures its pulse, and it's really slow, so he knows this star must be incredibly bright. But when he looks at it through his telescope, it's incredibly dim. There's really only one possible conclusion. It has to be unimaginably far away. And just like that, poof, the universe exploded in scale. Andromeda wasn't some little cloud inside our own Milky Way. It was an entire island universe, a galaxy, millions of light years away. This discovery didn't just add a new fact to a textbook. It totally changed our address in the cosmos. We went from thinking we were the universe to just one galaxy among billions. But right as we started to get a handle on the true scale of things, we slammed into another wall, a new problem. We were basically trying to look at the entire universe through a dirty, shimmering, blurry window, and that window was Earth's own atmosphere. You see, our atmosphere makes starlight twinkle, which is pretty, but it's actually distortion. Our cities create so much light pollution that they just wash out the faintest objects. And maybe the biggest problem of all, the atmosphere acts like a shield, completely blocking whole types of light, like infrared and ultraviolet, from ever reaching the ground. The next step was obvious. We had to go to space. And so in 1990, we launched the Hubble Space Telescope. Its biggest advantage wasn't just the crystal clear view. It was its ability to see light that's invisible to us. See, because the universe is expanding, light from the most distant objects literally gets stretched out on its journey across billions of years. This stretching shifts visible light into the infrared spectrum. So if you want to see the oldest things in the cosmos, you have to be able to see in infrared. And by seeing this old light, Hubble did some incredible things. For the very first time, we were able to pin down the age of the universe with amazing precision, 13.8 billion years. It was just a monumental achievement, something we could only do by putting a telescope above our atmosphere. But even the mighty Hubble, for all its power, had one last limitation. Because it orbited so close to us, it was constantly bathed in heat and infrared light coming off the sun and the Earth. This interference, this noise, meant it could see some infrared light, but not the deepest, oldest, faintest light from the very dawn of time. And this led to the ultimate question, the one that drove this next massive leap in technology. How do you build a machine that can actually see the very first stars and galaxies switching on at the beginning of everything? And here is the absolutely breathtaking solution they came up with, the James Webb Space Telescope. First, you send it 1 million miles away from Earth. Then you park it in the Earth's shadow, where it can stay super cold and dark. You give it a massive gold-plated mirror to catch the faintest possible photons of light, and you tune it to look only for that super stretched-out deep infrared light, the oldest light in the universe. And so the whole journey just comes full circle. It starts with Galileo proving we're not the center of everything. Then Newton's mirrors let us build bigger eyes. Then Edwin Hubble finds a whole universe of other galaxies, and the Hubble telescope finally measures its age. And now, the JWST, built specifically to see the very beginning. Each one of these massive leaps was only possible because of the one that came before it. But here's the thing, and this is always how it goes. True to form, the James Webb isn't just spitting out easy answers. Its vision is so new, so powerful that it's showing us things that are raising entirely new questions, things that are actually challenging our current models of how the universe works. And really, that's the true legacy here, isn't it? Every great telescope in history has solved one mystery, only to reveal an even deeper, more profound one waiting behind it. So the final question isn't just about what the James Webb will find, it's about what new, incredible questions it will force all of us to ask next.